Well, the skew is more important. Like if you lost.
Yeah, it's really exciting.
What?
Slide. See how it is? Okay.
Is this positive or negative skew?
Positive.
This is positive skew. Makes not a bit of difference if there's only negative numbers on here, right? Positive or right-hand skew. Positive or right-hand skew. So, what have I drawn?
The mode.
This is the mode. What's this?
Mean.
And then what's probably this?
Mean.
The mean, right? Good. Why?
Which one is the middle one?
Median.
Mode, median, mean. Why? Yeah.
The mode wouldn't change because it's still top mountain.
Unaffected by skew, right?
Median would move slightly because it would take into effect outliers, but only move one per outlier.
Right.
And then mean would move closest to the outliers because it's most affected.
By skew, by any extreme values. Influenced by every single, the actual value of any extreme values. I would be able to articulate that. Great, you can label a graph, but please be able to tell me why you have labeled it that way. Yeah? So this is just the reverse, right? Positive or negative skew? Negative skew, skew to the left, right? And so, what have I drawn? The mode.
Median. Mean.
Right. Does that make sense? Be able to tell me why. Why did we label it that way? And please don't write because I memorized it. Okay. And know that if it's positively skewed, it's skewed to the
Right.
and if it's negatively skewed, it's skewed to the
Left.
right. Know those things too.
Wait, Professor. So, with that kind of what you just showed us, you still say that the median's the best measurement to go by?
With skew, it's usually a good idea to report both mean and median, because then you get a sense of the extent of the skew. And oftentimes in psychological literature, when you have any kind of skew, you get both mean and median reported.
Okay.
All right, so I've made this roughly symmetrical graph, right? So it's roughly symmetrical, so where would the mean be?
In the center.
In the center. Okay. What? Okay.
Yeah.
Where would the mean on this one be?
Middle.
In the middle. Which one of these has the bigger standard deviation? A or B? A, right? Because there are so many more people far away from the average, right? Good.
What's the question?
Which one of these has the bigger standard deviation? A, right? But I imagine I'm going to make it a little more challenging than this thing that I just taught you right now. Remember though, if there are more people far away from the average, then if the units of measurement and the variable is the same, then you're going to have a bigger standard deviation in the one where there are more higher bars far away from the middle, right? Rule of thumb. Be able to interpret graphs like that. thing that we did in here was we learned all about the rules of thumb for the normal distribution. They're not really rules of thumb. We learned about the breaking points on a normal distribution, right? If we think about, if we set the average at 0, and we say, okay, here is 1 standard deviation above the mean. You see that? 1 standard deviation. Here's 2 standard deviations above the mean. You see that? Here's 3 standard deviations above the mean. Here's 1 standard deviation below the mean. Here's 2 standard deviations below the mean. And here's 3 standard deviations below the mean. Right? Remember that? So let me give you an actual example with different numbers. Let's just use IQ as my working example, because I like that one. The average IQ is 100. The standard deviation is 15. So this would be 115, 130, 145. Down here would be 85, 1 standard deviation below. This would be 70, and this would be 55. Right?
So are you going to give us like this on the exam, or will we have to draw our own lines?
I anticipate you will not be drawing any graphs on the exam, but interpreting graphs on the exam. I do not want to evaluate people's artistic abilities. Not interested. All right, so what proportion of people are from here to here?
68.
68%, or a proportion of 0.68, right? What proportion of people are from here to here? The exact same thing, right? 0.68 is the proportion, 68%. So be able to apply your knowledge to an actual example, right? So if I said, what proportion of people if IQ has an average of 100 and a standard deviation of 15, what proportion of people, or what percentage of people, are going to have IQs between 115 and 85? 68%, if I asked for a percentage. 0.68 if I asked for a proportion, right? Make sense? But what happens if I ask, well, what proportion of people have an IQ between 1 and 2 standard deviations above the mean? I want to know in here, right? Now I want to know in here. I might ask something like that, right? How in the world would I figure that out?
Well, it's 95.
Right. So from here to here, it's 95%, right?
Yeah.
So half of 95 would get me from here to here, right?
Yeah. And then it's half of 68.
I might recommend, theoretically speaking, on your own, or we can even do it in here, maybe it'd be a good idea to know what all of these different sections are. Wouldn't that make your life on the test easier?
Do we have the whole period to do the test?
You have the entire class. So let's do that now, shall we? So these center ones are 34 and 34, right? All right. So if I ask for a percentage, you still need to round 2 places after the decimal point, right? For a proportion, you still have to round 2 places after the decimal point, right? So just keep track on the exam. If I ask for a percentage and you give me a proportion, I will mark off. If I ask for a proportion and you give me a percentage, I will mark off. Make sense? Okay. So, since 68% is in here, then 34% are in these 2 sections here, right? I will label the sections for you. So the sections labeled A and B have 34% in them, right? Let's call these C and D. C and D will have the exact same, right?
13.5.
Is it 13.5?
Yeah.
Are we in agreement? How did we figure that out?
95
So we did 95
minus 68
minus 68
divided by 2.
divided by 2. Right? Does that make sense? So it's 13 and a half in here, right? You see that? And that means it's 13 and a half in here, right? If I were me, if I were you, I mean, you could just figure it out on the exam, right? But this would be so much easier on the exam to just know these percentages, right? Wouldn't it? Super would. All right, so now let's have A, B, C, D. Let's do E and F. Well, what is it from -3 to +3?
9.7.
So from here to here is 95. From here to here is 95. From here to here is 99.7. So how do I figure out what's in here?
Subtract 9.7 has 95. You have that too.
What's that? Yeah? 2.35%? All right. What about beyond? Well, if everything on the inside is 99.7, what's left over? 0.3, right? That's what's left over. And so what's half of that? Right? This would make any problem about this graph much easier to answer, right? I thought about that after our last discussion. I thought this might be good to just do in this class. So if I ask you from here to here, then you say 13.5. If I ask you from here to here, you just add all three. If I ask you, right, it just becomes easy. Much easier anyway. I thought this was a useful exercise. But keep in mind, but now, let's make sure we can turn these into proportions. So if I was going to report these as proportions, this would be 0.0015, right? Or, right? This would be 0.0235, 0.135, 0.34. And you don't know which I'm going to ask you. And I think knowing the difference in a percentage and a proportion is important enough that you just have to keep track of which one I'm asking for. Does that make sense? Yeah? All right. There may be labeling when it comes to this. I may ask you scenario questions, like here's a variable with a particular average and a particular standard deviation, and you would have to apply this to something like this. Keeping track of, oh, what does she say the average is? What does she say the standard deviation is? Does that make sense? You need to be able to move back and forth between this. So here, let me do one more variable. Let's say the average number of video games in the class is 6 and a standard deviation of 2. What goes here?
8,
What goes here?
10,
What goes here?
12,
This is 4, 2, and 0. So what proportion of people, well, negative video games, I don't even know what that would mean, right? But what proportion of people are going to have between 8 and 12 video games?
0,
Between 8 and 12 video games. Do you see that's who I want?
15.85.
0.158.
So it would be
Oh.
13, so it would be 13.5 plus 2.35, right?
0.15. 15.85.
So if it's percentages, it's 15.85, right?
Right.
If it's a proportion, it's 0.15, 0.16 if you're rounding to two
Oh.
places.
Okay.
It's always two places after the decimal point, which shifts things if you're going from percentages to proportions, right? Yes.
For the proportion of 0.15%, do we write 0.0015?
Well, if I ask you for a proportion, this would be the proportion. If you decide to round to 0, that would be okay.
So both will be okay?
Both would be fine.
Okay.
You can always round to two places after the decimal point, always.
Okay. So that's fine too.
Just write 0.
But if I ask you for percentage, can you tell me 0?
No.
Nope. When we talk about p-values later, we're going to learn, and probabilities, we're going to be talking in terms of proportions a lot. It's just, it's difficult with English, for whatever reason, to talk in terms of proportions, and so we often express things in everyday language as percentages, and I just want to make it very clear the relationship between proportions and percentages now.
So
Yes.
for the- okay.
Oh, and then, yes, and then back, yeah.
Oh, you mean,
Go ahead.
Are you sure? Okay. So for the second one, you can do 0.024.
Yes, if you, really, you could round to this.
Oh yeah, okay, sorry. Okay, I got it, thanks.
so more than 2 is fine, but no less than 2.
Yeah, more than 2 is 5. If you want to give me 4 places after, 5 places after, I'm a happy camper, but less than 2, I'm going to take off credit.
Okay.
All right, study that, know that, you should be in good shape.